Welcome to UGC EPG Pathshala. Hello everyone, I am Dr. Anshu, teaching geography at Kirorimal College, University of Delhi. I will talk to you about earthquakes, their study, science and types. We know it is a geomorphic phenomena, event caused majorly due to movement in the earth's crust. Let us begin with definition of earthquake. Earthquake is vibration of the earth caused by shock waves due to sudden release of energy that results from sudden displacement along faults or movement of magma or sudden ground subsidence. The energy is abruptly released after a long and slow accumulation of strain along a fault. The adjustments of the earth's surface after the initial earthquake generates series of low intensity earthquakes referred to as aftershocks. The scientific study of earthquake is called seismology, derived from Greek seismos meaning earthquake and logos meaning reason or speech. Data from seismology have become an integral part of the modern day scientific understanding of the constitution of the earth's interior. We shall now understand modern seismology and the important terms associated with earthquakes. The credit for developing the science of seismology goes to a group of British scientists, chief amongst them being John Milne, who is credited for the creation of the instrument known as seismograph that is capable of detecting signals from distant earthquakes. The seismograph consists of an inertia member, a transducer and a recorder. The inertia member is a weight suspended by spring so that it acts like a pendulum, but is capable of moving in one direction only. The inertia member tends to remain at rest as the earth waves pass by. The transducer is capable of detecting the relative motion between the mass and the ground, which it converts into a recordable form. A standard recorder is a cylindrical drum with a sheet of recording paper wrapped on it. It produces a series of parallel lines. When an earthquake strikes a place, these lines move in response. Two important terms that are frequently used while discussing earthquakes are epicenter and focus of an earthquake. The point at which the energy is first released is the focus of the earthquake or the hypocenter. Epicenter is the place on the surface of the earth which is directly above the focus. For instance, the December 26, 2004 earthquake that triggered the devastating tsunami in the Indian Ocean had an epicenter 160 kilometers off the west coast of northern Sumatra and a focal depth of 30 kilometers. Depending upon the focal depth, three categories of earthquakes can be recognized: shallow focus, intermediate focus and deep focus. Shallow focus earthquakes occur at less than 70 kilometers depth, while the intermediate focus earthquakes have focal depths between 70 and 300 kilometers from the surface, while those with the foci located at a depth of more than 300 kilometers are categorized as deep focus earthquakes. Here, it is interesting to note that shallow focus earthquakes are the most destructive because energy released has little time to dissipate before reaching the surface. The earthquake processes that are identified include faulting, tectonic creep and slow earthquake. Let us understand each one of them separately. First, we will talk about faulting. A fault refers to a crack or a fracture in the earth's surface, and faulting refers to the process of fault rupture. As the two lithospheric plates move past each other, they are slowed down due to friction along their boundaries, producing strain and deformation in the rocks. Increase in stress in these rocks over their strength leads to rupture, forming a fault or a crack and producing earthquake. Rupturing starts to occur at the focus of the earthquake and continues to move upwards, downwards and laterally. In this process, the stored energy is released, producing shock waves or earthquake waves or seismic waves that vibrate the ground. The second process that we mention here is the tectonic creep. Tectonic creep refers to faults displaying gradual displacement and usually not accompanied by earthquakes. This process, however, can be potentially damaging, causing deformation of roads and other standing structures. And lastly, let us look at the process of slow earthquake. Slow earthquakes are relatively newly recognized earth processes, also produced due to fault rupture. The rupture is relatively slow and may span over several days and even months. Their magnitude varies between 6 and 7 as they are located over large areas of the rupture. The amount of slip is generally very small, up to a few centimeters. The continuous geodetic surveys and measurement with global positioning satellites has aided in the identification and recognition of these earthquakes. An interesting fact to highlight here is that more than 90,000 earthquakes are recorded annually worldwide. Majority of these are too small to be felt but are nonetheless recorded. It is observed that only about 30% are strong enough to be felt. We shall now focus our attention on the types of seismic waves that are generated during earthquakes. When an earthquake strikes a place, it is the seismic waves that cause strong motion, crack the ground and causes immense damage to standing structures and buildings. The energy released during earthquake moves mainly in two forms of seismic waves, radiating in all directions from the focus: body waves and surface waves. While the body waves travel through the solid body of the earth and are analogous to sound waves, the surface waves travel along the ground and are similar to waves on water surface. Two types of body waves may further be recognized. These are P waves and S waves. P waves or primary waves are the fastest moving seismic waves and are felt first. They can travel through solids, liquids and gases. P waves are similar to sound waves and are compressional waves propagating in same direction as the waves themselves in to and fro motion. The material through which the P waves travel compresses and expands as the waves move through it and comes back to its original position, and once the waves have passed by. S waves or secondary waves travel slower than the P waves and can travel through solids only. S waves are also called shear waves due to strong side to side and up and down shearing motion. S waves cannot be transmitted through liquids because liquids are not rigid and therefore they have no shear strength. The P and S waves travel at different velocities that are determined by the density and elasticity of the materials through which they travel. The velocity of P waves is greater than S waves in all types of media, and thus P waves arrive first at recording seismic stations. The P and S waves travel times are published in time distance graphs that illustrate the difference between the arrival time of two waves as a function of the distance between the arrivals of the two primary and secondary waves. Since the two waves have varying velocities, P waves travel at about 6 kilometers per second through bedrock, while the S waves travel at about 3.5 kilometers. The distance to the earthquake focus can be calculated. Let us now see the different types of surface waves. The movement of surface waves is limited to the ground or just below it. These are slower than the body waves and arrive just after the S waves. Two important surface waves are Rayleigh waves and Love waves, named after the British scientists Lord Rayleigh and A.E.H. Love respectively. Rayleigh waves are slow waves and behave like water waves, wherein the individual particles of the material move in elliptical path within a vertical plane oriented in the direction of wave movement. Love waves are similar to an S wave, and the individual particles move only back and forth in a horizontal plane perpendicular to the direction of wave travel. In the following talk, I shall tell you relationship between plate tectonics and earthquake. For explicit information on plate tectonics, you can also view the module on plate tectonics. The distribution of earthquakes is closely related to plate boundaries, as the earthquakes are triggered by the motion of the Earth's crust. That is, when the plates move either towards each other, away from each other, or slide past each other. Let us see what happens when at each of these plate boundaries. At divergent plate boundary, the magma upwells through the opening between the plates. This boundary mostly marks the mid-oceanic ridge and may be an active or extinct spreading ridge. The basaltic lava spews out from the ocean floor and produces line of volcanic vents. In these spreading centers, shallow focus earthquakes are common. The rupture that produces the earthquake are up to 70 kilometers in depth. Earthquakes are common in the continental rift valley that are divergent boundaries developing within a continent. One such example is Rift Valley of Africa. As the Arabian plate moves away from the African plate, formation of Red Sea and Gulf of Eden is taking place. This 3,000 kilometers long East African rift system extends from a far triple junction to Mozambique. The scientists are of the belief that this continental rift valley will develop into oceanic spreading centers such as the mid-oceanic ridge. The second type of boundary is the transform plate boundary. Let us see what happens here. There is a great deal of seismic activity when laterally the lithospheric plates slide past each other across vertical fractures commonly referred to as transform faults. This zone is famous for occurrence of shallow focus earthquakes. The transform fault mostly occurs along short offsets related to slight bends in the mid-oceanic ridge system. But in some cases, such as San Andreas Fault in California, the transform fault extends through continental lithosphere. On April 18, 1906, earthquake of magnitude 7.9 struck California. Other examples of transform fault in continental lithosphere are the Alpine Fault in New Zealand, Queen Charlotte Fault in North America, and Anatolian Fault in Turkey, which are witness to several shallow focus earthquakes. An earthquake of magnitude 7.8 struck Canada along the Queen Charlotte Fault in 2012. Finally, let us understand what is happening on the convergent plate boundaries. The lithospheric plates collide as they move towards each other, forming convergent boundaries. These are also called the destructive margins, as here there is compression or removal of Earth's crust. Convergent boundaries can be of three types: oceanic continental, oceanic oceanic, and the continental continental boundaries. In case of oceanic continental convergence and oceanic oceanic convergence, subduction of the denser stratum takes place with a great deal of seismic activity. In oceanic continental convergence, the oceanic crust, being dense, subducts under the continental plate, leading to shallow focus earthquake at the trench that is formed. Deep focus earthquakes originate at more than 700 kilometers as the subducting plate descends into the asthenosphere. These earthquakes are produced by slip on the subduction thrust fault as the oceanic plate is pushed into mantle. This zone is also referred to as the Benioff zone. There is concentration of shallow focus, intermediate focus and deep focus earthquakes along the circum-Pacific belt, also referred to as the Ring of Fire. The Pacific plate subducts into the North American plate, forming the Aleutian Trench, where earthquakes are a common feature. As the Nazca plate subducts beneath the South American plate, Peru-Chile Trench is created. In the Indian Ocean, the tsunami of 2004 was triggered by earthquake in Sumatra, Indonesia of magnitude of 9.1 along the mega thrust where the Indo-Australian plate subducts under the Burma plate, which is considered part of the Eurasian plate. Large subduction zone earthquakes have continued to occur along this belt. Nias Island earthquake of magnitude 8.6 in 2005, 8.5 and 7.9 magnitude earthquakes in 2007 and 7.8 magnitude earthquake on portion of megathrust west of Mentawai Islands in 2010. In case of oceanic-oceanic convergence, one oceanic plate subducts under the other, leading to formation of oceanic trenches. The earthquakes, both shallow and deep focus, occur during this convergence. Mariana Trench is result of convergence of fast moving Pacific plate against the slow moving Philippine plate, which is also zone of earthquakes. The continental convergence has no subduction due to buoyancy of the continental crust, but shallow focus earthquakes are quite common. The formation of huge mountain ranges such as Alps and Himalayas is attributed to this type of convergence. Earthquakes in Himalayas are common as the Indian plate and the Eurasian plates continue to converge at relative rate of 40 to 50 millimeters per year. In Nepal on 25th April 2015, shallow focus earthquake of magnitude of 7.8 occurred that devastated the small Himalayan nation. The epicenter was located 36 kilometers east of Khuddi in Nepal and was followed by aftershocks of magnitude 6.1 and 6.6 on April 25th itself and 6.7 on April 26, 2017. In 2016, on 3rd January, 6.7 magnitude earthquake occurred 30 kilometers east of Imphal in India. Now, we will understand what are the major causes of earthquakes. Most of the earthquakes are caused by the deforming forces in the earth, and the immediate cause is the sudden rupture of the earth materials distorted beyond the limit of their strength. Elastic rebound theory propounded by Reid is used to explain how earthquakes originate. After the 1906 San Francisco earthquake, H.F. Reed, scientist at the Johns Hopkins University, conducted a study to understand the mechanics of earthquake. The field study showed that during this earthquake, the Pacific plate had moved past the adjacent North American plate by as much as 4.7 meters. According to Reed, tectonic stress builds up over hundreds of years, deforming rocks on both sides of a fault. When rocks experience continuous stress, they bend and store elastic energy. As soon as the strength of rock is exceeded, it snaps back and rebounds to its original position and shape. Since the rocks behave elastically like stretched rubber band, Reed termed it as elastic rebound. In this process of rocks snapping back to the original unstrained position, vibrations are generated that are felt as tremors or earthquake. During the San Francisco earthquake, along the San Andreas Fault, straight line fences and roads that crossed the fault gradually bent as the rocks on both sides moved relative to each other. Earthquakes are also induced by anthropogenic activities that cause widespread havoc and destruction. Three ways in which human activities trigger earthquakes include load of dam or reservoir on the crust, waste disposal in deep underground wells, and nuclear explosions. Let us see how reservoir and seismicity is interconnected. Reservoir-induced seismicity has triggered hundreds of earthquakes. The construction of Ziping-Pu Dam induced the 7.9 magnitude Sichuan earthquake in May 2008, in which more than 80,000 people lost their lives. As the dams are constructed, extra water pressure is created in the micro cracks and fissures in the ground and near the reservoir. The increased pressure of water in rocks acts to lubricate faults already under tectonic strain, but have remained in place due to friction of rock surfaces. Deep waste disposal also induces earthquakes. Injecting waste into deep disposal wells, like disposal of produced waters from oil and natural gas wells, has been known to cause earthquakes. The 2011 Oklahoma earthquake of magnitude 5.6 is believed to be the strongest earthquake induced by injection of waste materials. Nuclear explosions have been known to cause earthquakes with large magnitudes like M5 to M6.3 that are triggered off by underground nuclear explosions. This was because the explosions caused simultaneous release of natural tectonic strain. So many times, mining and quarrying activities alter the balance of forces in the rock, many times causing rock bursts and thus inducing earthquakes. But then we would like to know how to measure these earthquakes. Earthquakes are measured on basis of their magnitude and intensity. The amount of energy released during earthquake at the source is quantified through magnitude. It is measured with the help of seismographs that plot the earthquake waves traveling through the earth. Two measures for earthquake magnitude are the Richter scale and the moment magnitude. What is a Richter magnitude? Using seismic records, Charles Richter in 1935 from California Institute of Technology developed the first magnitude scale. The amount of ground displacement and shaking produced at the epicenter is measured on the Richter scale. It is a logarithmic scale, which means that each successive magnitude is 10 times stronger than the previous one. Magnitude 2 means that the energy release was 10 times more than that was released during earthquake of magnitude 1, and in magnitude 3 it is 100 times more than the energy released at 1. The scale calculates the amplitude of the seismic waves P, S and surface as they are recorded by the seismograph. Although earthquakes of smaller magnitude occur each day on the lithosphere, the most devastating ones are with more than magnitude 8. Let us know what is moment magnitude. An improvement over the shortcomings of the Richter scale, the moment magnitude scale has been developed to measure the relative energy release. It is calculated by measuring the average slip on the fault, the area of the fault surface that slipped and the strength of the faulted rock. This method is especially useful for measuring the large earthquakes. The largest earthquake which took place in Chile in 1960 had a Richter magnitude of 8.9, but an estimated moment magnitude of 9.5. All magnitude scales are logarithmic in nature. Lastly, let us look at intensity. The intensity scale is devised to interpret the qualitative measure of damage by the earthquake. News headlines vividly discuss the aftermath when an earthquake strikes a place. It gives us information about the death toll, the destruction and other such tragic details of the damage caused, all of which basically tell us how intense the earthquake had been. Modified Mercalli intensity scale has values ranging between 1 and 12, where 1 means that the earthquake is not felt except by few and 12 is total damage of the structures. Let us summarize by saying that earthquakes are the vibrations in the earth caused due to the tectonic movement of lithospheric plates. The types of seismic waves generated during the earthquakes are P, S and surface waves. The earthquakes are categorized according to their point of origin or focus as shallow focus, intermediate focus and deep focus. Earthquakes of shallow focus and intermediate focus are common on divergent and transform plate boundaries. The deep focus earthquakes occur in the subduction zone of oceanic-oceanic and oceanic-continental plate convergence. The magnitude and intensity of earthquake is measured by Richter scale and modified Mercalli scale respectively. This was all about the earthquakes for today. Thank you all and happy learning.